Hello and welcome to this Dwarfputing series. In this episode, we're going to be talking about mechanical logic. So in the previous episodes, we talked about signals, signal repeaters. While you can do a lot with signals by themselves, we still need a way to process them. And to do that, we need some system of logic. So something that uses a signal to control something outside the signal realm in some other realm. And then, convert that back into signals, or just, use the effects in that realm as is. So one way of doing that is mechanical logic. There are other logics as well, fluid logic, creature logic. We might get into those in another episode, but in this episode, we're focusing on mechanical logic. Okay, so first off, we have some mechanical logic gates. So from top to bottom, we have a NOR gate, NOR, an AND gate, AND, XNOR, XOR, XOR, and then NAND and OR. So NAND and OR. If we look at how the NOR gate works, so we can see both off, lets the signal go through. If at least one of these are pulled, there is no power transmission. The AND gate basically only transmits power if both these levers are pulled. The XOR gate basically, because of course gear assemblies are toggles, both the levers are actually linked to the same gear. So the XNOR basically transmits power if they're both in the same state, but doesn't transmit power if they're in different states, as you can see. And the XOR gate is basically just the exact opposite of that. As you can see, pulling one of them switches where the power gets transmitted from. The NAND gate basically is a not AND. So basically, as long as at least one lever is in the off state, power will get transmitted to you. And then the final one is the OR gate. If at least one of the levers is in the on state, power will get transmitted. So like so. So those are the basic gates. The bauxite gear assemblies, as opposed to the jet ones, basically we create a lever and just connect each red gear assembly to the lever and pull it once and then delete the lever so that its default state is inverted. Now, there's a lot you can do with gates alone. Sometimes you'll want a more complicated function or predicate on the state of some inputs. So for this, we're going to talk about disjunctive normal form. It's useful in some instances. Obviously, the more inputs you have, your circuit size is going to explode. So I'd only use this to simplify, the construction process for, a very small subset of inputs. But basically, disjunctive normal form is a disjunction of conjunctions. And what is that? So it's basically an OR of a bunch of ANDs, right? Say you have, a bunch of, variables, atomic variables. So this is what the levers are representing. So if we put them all in the off state, they're off. And then, a conjunction of those would be like this and that and not the other one, right? So this gear assembly is going to be activated when this lever is off, this one when this one is on, this one when this one is on too. And what this circuit I've done here does is it basically activates the power when at least two of these levers are pulled. So as you can see, like that. Pull the left two, same, we get power. If we unpull the middle, and we get power again, right? We could turn off the power like that. So that's sort of how you can use disjunctive normal form to create effectively sort of tables of, combinations of signals that would produce an output. Now, the final thing I want to talk about is, how do you convert power, mechanical power, into a signal? So the way you do that is using a power to signal converter. And there's, this is sort of the lowest latency example that I know of. Basically, there's a roller here that pushes off to the right. And it sends a minecart onto this pressure plate, which, opens this door if there's power. So if there's a consistent source of power, that pressure plate will be pressed. And it will never have the chance to depress. So that door will be held open. And as soon as we disengage the power, the minecart comes to rest blocked by this wall. And both these walls are necessary because otherwise the minecart would shoot off in a diagonal. But yeah, you can see once the power is disengaged after 99 ticks, the door closes. Okay, I hope you enjoyed that episode. Thank you very much for watching.